Hello everyone, welcome back to Mr. Lee's Math Class Videos. I'm Mr. Lee. We're picking up at the beginning of 7.6 Part 2, just looking at, we stopped where we looked at x was equal to these values, 3x, and x over 2 is equal to those values. Now what that really tells you is that x is equal to pi over 4 here, and x is equal to 5 pi over 4. In this case though, it's not that way. You'll get 3x is equal to pi over 4, 5 pi over 4, 9 pi over 4, 13 pi over 4, 17 pi over 4, and 21 pi over 4. Because it's not x anymore, it's now 3x. If you wanted to find the actual x values, you have to divide both sides by 3 in the case of all of these. So that if you divide them all by 3, it's like multiplying 3 into the denominator. This is pi over 12. 5 pi over 12. This would be 9 pi over 12. That will reduce to 3 pi over 4. 13 pi over 12. 17 pi over 12. And 21 pi over 12, again, is going to reduce to 7 pi over 4. So what you actually notice is that when you head back to x, all of these values actually do end up between 0 and 2 pi. For this one, you get x over 2 is equal to pi over 4, multiply by 2, so you get that x is pi over 2. So what this actually produces is that these angles don't actually match up, even though the equations match up with just a slight different change on the left side. Because that's what the angle is, if the inside is pi over 4, that will produce the answer. But the inside being pi over 4 will change what x has to be in order to make the inside match that. So it'll produce the answers. And you'll notice when you go back to x here like this, all of these x values are between 0 and 2 pi. So in general, how does this work? If you're taking the all solutions equations, you also would like to solve them for x. So even though this one is fine, if I were to take this equation and solve it for x, I also have to divide it by 3. So you actually get x equals pi over 12 plus pi over 3n. So every pi over 3, it repeats because you're going 3 times as fast. And you'll notice when n is 1, pi over 12 plus pi over 3, that's 5 pi over 12, n equals 2, n equals 3, n equals 4, n equals 5. So that covers almost all of them until n equals 6, because 6 over 3 would be 2 pi, and that moves you a whole revolution. Similarly, if I were to solve this, x over 2, when you double it, you're going to get that pi over 2, but when you double the pi n, it actually repeats every 2 pi, because it's going more slowly. So even though this equation will match for all of them at the starting point, you still have to manage them from there. And I think this is the easiest way to start, to find the locations, and then find the proper final values by dividing by whatever's there. But in general, we know one revolution around the circle usually produces 2 solutions. But if whatever number multiplies by x in there, that should multiply your solutions by that many. So 3x, 3 times 2 is 6. Half x, half of 2 is 1. Now it doesn't always line up, in particular with the fact that sign is positive in the first half of the circle and then negative in the second half, but on average, it should create fewer solutions if there's a fraction or more if there's not. If there's a whole number or a multiplier that's bigger than 1. So let's practice doing this. 2 times the sine of x over 2 equals 1, which means sine of x over 2 equals 1/2. As a real note, if x is between 0 and 2 pi, then x over 2 will be between 0 and pi. Now, which values produce a sine of 1/2 on the unit circle? X over 2 is going to be equal to either pi over 6, our 30-degree angle in the first quadrant, or 5 pi over 6 in the second quadrant. Let's just make sure when you multiply the 2 to the other side, x is equal to 2 pi over 6, or x is equal to 10 pi over 6, which is what? Pi over 3 and 5 pi over 3. Are those both between 0 and 2 pi? Yes. When I do this over here, though, x over 2 equals pi over 6. How often does sign repeat? Every 2 pi. X over 2 equals pi over 6, or 5 pi over 6, plus 2 pi n. When I multiply this by 2, I will get that same pi over 3. But now when I double the 2 pi n, it's now 4 pi n. Here, same thing. 5 pi over 3 plus 4 pi n. So you just keep track of the various rules. Recognize what your angle is inside originally, so you can set it equal to things, and move from there. This also lets you do things like 3. We'll do one of them and leave the other one for you. So cosine of 2x equals cosine of x. This is somewhat problematic in many ways, but we're going to look at a way to deal with this. This will use your double angle identity to be clever. Cosine 2x, I would like to convert to the one that has cosine only because I know that I have a cosine on the other side. That's 2 cosine squared x minus 1. So that means I really have a 2 cosine squared x minus 1 equals cosine x. This is quadratic, so we want to set it equal to 0. 2 cosine squared x minus cosine x minus 1 equals 0. It's just on 0 to 2 pi, so this one doesn't want all of our intervals. It's really just seeing how now our new learned method will interact with the other ones. When you factor this, this should factor into 2 cosine x plus 1 and cosine x minus 1 equals 0. You can FOIL this out to make sure. 2 cosine squared plus cosine minus 2 cosine x will produce the negative. Positive and negative 1 multiplied together will produce the negative 1. And we know now that if two things multiply to be 0, one of them has to be 0. So this one will produce 2 cosine x equals negative 1, which means cosine x equals negative 1/2. Here we get cosine x equals 1. If we look at these intervals, cosine x equals 1 at 0. Here, cosine x equals negative 1/2. Cosine is negative in the second and third quadrants. It's the pi over 3 angle in those quadrants, respectively. That produces a cosine value of 1/2. So this should be 2 pi over 3 and 4 pi over 3. And from there, it just continues. Now you can always check what happens when you plug in 2 pi over 3. Is the cosine of 4 pi over 3 equal to cosine of 2 pi over 3? Well, we just said it. They're both negative 1/2. However, 4 pi over 3 and 8 pi over 3, well, 8 pi over 3 is all the way around the circle one time, plus another 2 pi over 3, so it actually is true as well. So there are times where you have to cleverly pick the identity that you're going to convert into, and I'll leave B for you guys to practice. It's very similar. Just remember, sine of 2 theta only has one identity you can convert to, 2 sine theta cosine theta, and because it has 2 different trig functions, that's where you have to subtract everything to one side and factor from there. But we'll continue at the end of this section in the next video.